Alright, so now before open close the principle, we have this diagram which is ugly, which is the same as I have shown you before, but that's kind of with a couple of spaces around it. So it's the same diagram and it's kind of ugly, it's spaghetti. We have a lot of stuff going on in this class and isn't right. There must be a better way. So we need to visualize our new decoding utility class, and how can we visualize it? Right, first we have this our decoding utility class. We're simply just announcing it there, and we will start by making a new interface for decoder interface, and we will also have another interface, and it's gonna be optional interface for the hash map, which is related to the data, like date, type, and country. Alright, now we have added our two interfaces which we will be using later on. We will start by making a class for a single brand. Like now we have a class for each brand. We start by Samsung, which we have Samsung decoder, and we will implement this decoder interface and the optional hash map. And we also will have an LG decoder, which will be implementing the decoder interface and optional hash map as well. And if we want to add another one like Toshiba, for example, it will be applying whatever is required. So if we don't want to implement the interface of the country or type or whatever, we can just simply remove it and ignore it. But for the sake of this example, I will implement both of them. And now, after making the Samsung decoder, LG decoder, and Toshiba decoder, every brand decoder, then I will make another class which is called adapter factory, that's gonna be responsible for taking all the decoder implementation, and after taking each of these decoder implementation, it will return as a correct type to the decoding utility, providing a high level of abstraction where the decoding utility class will no longer need to know the implementation of each of Samsung decoder or LG decoder or Toshiba decoder. It will be only required just to have some knowledge that it needs this kind of function, but it doesn't really need to know any kind of implementation of that function. So that's what we're gonna do now. Let's say we want to add another decoder. How can we just add another decoder? It's gonna be very simple and straightforward. We're just gonna make any other brand decoder, and we will make connection between the decoder interface and the optional hash map, and we will notify the adapter factory that hey, we have created a new brand. And this way we have never changed this decoding utility class. We only need to change this other brand decoder, because this brand decoder will be containing the implementation of our contract of decoder interface with or without the optional hash map interface. Now, after having this kind of diagram, you will probably think, how can you come up with this solution? I think I'm not really the best with design patterns, but I think the bottom area, which is in red in this red container, it's called strategy design pattern, and in the middle area, by providing each type to that factory, and that factory provides for the decoding utility, that's called abstract factory design pattern. And by combining these two design patterns, we have this amazing diagram, which is much better than this kind of messed up spaghetti code. So that's it for our diagram. If you have a better visualization than this one, feel free, share it, comment it down. But this is the diagram which I believe it's gonna be scalable, it's gonna be easy to implement, and we will see how can it happen in action in code. So moving on, What's the outcome of what we have done here? Now we have added an organized strategy to scale our app by just simply adding another brand decoder which implement each of these interfaces and just notifying the factory. That's what we have done here. So all the hard work will probably be working in these classes, which is like Toshiba decoder, LG decoder, Samsung decoder, and so on. So that's for organized strategy. We have also added abstraction between the adapter and decoding utility class. So now decoding utility class will not be changed unless there's some major thing that is required to have decoding utility class. But we have organized it, the app, so we can change the classes of the decoder class, but not the decoding utility class. And now we are open to add more implementation of other brands, and we close the modification of existing working code unless business requirement says otherwise. So for example, in our case here, we can add any other brand, but we close the modification for Toshiba. Like if you want to add, let's say you have another brand, let's say Apple TV decoder. You will not need to change Toshiba, you wouldn't need to change LG, you wouldn't need to change Samsung, you wouldn't change the decoder interface, you wouldn't really need to change option. You would just implement a new class, and you would create a new class and implement the interfaces you have, and you will just notify the factory by adding its type. That's it for closing the modification. So now we can say it's open for extension, open for scaling other decoders, and close for modification where we don't modify more correctly working code unless business requirement has a change. For example, like decoding policy change it for some manufacturer, which we will be required to change our decoder class. So that's it for how can we use open close principle in our app. I hope I made it a bit clear for you to understand how can we benefit from this principle, and see you next time.